Next chapter, reciprocals of numbers. Reciprocal is a term we have come across and even used on several occasions, but we haven't really given it much thought. So, what is reciprocal? The reciprocal of a number is simply 1 over that number. That is, the reciprocal of x is 1 over x. Reciprocal of 5 is 1 over 5. Recalling from 1, we said that the reciprocal of 2 over 3 is 3 over 2. How exactly did we arrive at that? Following our definition, the reciprocal of 2 over 3 is 1 over 2 over 3. We said over simply means division, so we can have 1 divided by 2 over 3. Then we have 1 times 3 over 2, and that gives us 3 over 2. In simple language, to get the reciprocal of a fraction, you simply interchange the numerator and the denominator. In shorthand, the reciprocal of a number n is given as n raised to power of negative 1. And so the reciprocal of 2 is 1 over 2, or 0.5. Reciprocal of 10 is 1 over 10, or 0.1. Now, how about the reciprocal of 4.534? Following the above, this is 1 over 4.534. Can we do the long division? We have 1 divided by 4.534. Finding reciprocals of whole numbers is easy, but decimals? No. Luckily, we have tables of reciprocals of numbers from which we read the reciprocals of numbers. The tables give the reciprocals of numbers from 1.000 to 9.999. From a general view, the tables look much like those of squares and cubes, right? But careful, the last columns, the differences columns, are indicated subtract. So we shall subtract and not add like we did before. The rest is read as usual. So for our number, reciprocal 4.534, we go to 4.5 here. The column of 3 meets us here. Notice that all the numbers begin with 0 point. So our number here is 0.2208. We move to the differences group of columns and find the column of 4. It meets us here, and the figure is 2. We subtract from our previous reading, and we shall have 0.2206. For numbers less than 1 and greater than 9.999, we first express them in standard form. For example, the reciprocal of 0.0324. In standard form, that will be 3.24 times 10 raised to power negative 2, and then the reciprocal of everything. 3.2 is here. The column of 4 meets us here. The number is 0.3086. We have no third decimal place, and so we end here. What is the reciprocal of 10 raised to power negative 2? For this part, we simply change the sign of the power, so it becomes 10 raised to power of positive 2. So we shall have 0.3086 times 10 raised to power 2, and this is the same as 30.86. How about the reciprocal of 4,873? We make it in standard form. That becomes 4.873 times 10 raised to power 3. 4.8 is here, coincides with 7 here. The number here is 0.2053. To the differences column, we move down column 3. They meet here. The number is 1. We subtract and we get 0.2052. Now you will have noticed that the larger a number is, the smaller its reciprocal, and the reverse is also true. Let's see some applications of reciprocals. For example, evaluate 2 times 1 over 2.94. In this example, we first find the reciprocal of 2.94. The reciprocal of 2.94 is 0.3401. Then we multiply this by 2 and we shall get 0.6802. How about 3 divided by 0.4138? I would write that as a fraction, that is 3 over 0.4138, and then break it into 2 parts, 3 times 1 over 0.4138. These two are the same, it's only that the second one makes it easy for me to see the way forward. The reciprocal of 0.4138 in standard form, that is 4.138 times 10 raised to power of negative 1. 4.1 is here, the column of 3 will meet us here, and the number is 0.2421. The differences column of 8 meets us here, and the number is 5. When we subtract, we get 0.2416. Reciprocal of 10 raised to power negative 1 is simply 10 raised to power positive 1. So we have 0.2416 times 10 raised to power 1, or simply 2.416. And then we multiply this by 3, and we shall have 8, 4, 2, the decimal, and then we shall have 7.
I think one of the problems with math is if you aren't strong in it, you end up with weak spots in the foundation. And so if you want to build on that, if you want to go in and major in it or to do honors in it, you really do need a solid foundation. And so if you don't have it, if you've had a bad experience with math, you tend to sort of slough it off, and that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place. And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university.